What if I told you that the limitations of your eyes, or the way your eyes work, actually matches the curvature of the Earth? Don't you think that's quite a big coincidence?
Is it possible the way our eyes work, the way we see, is mistaken for Earth curvature? Let's find out. Okay, first I'm going to show you a couple clips from a video, and then I'll leave a link if you want to watch the whole video later.
If you take the angular resolution limit of the eye, right, that you can get the radius value of the Earth to the exact decimal place. All right, the angular resolution limit of the human eye is about 1 arc minute, or approximately between 0.02 and 0.03 degrees.
Now, using 1 arc minute, or 0.02 degrees, a 6-foot observer, the horizon should be about 2.9 miles.
Scientifically, that's how your eyes function. Now let's see if it matches reality. Okay, this is a great place to show you because here we can take a look at if science matches up to what we see. Let's take a look at some measurements out here on the lake using Google Earth. We're at the Southbridge boat launch. Okay, so let's cruise out this way. And our first measurement here, I'm going to show you a tree at about 3 miles away. Okay, so here's these two trees at 3 miles, and here's a marker, and here's a marker. Okay, so now let's move over this way, and we're going to go to Strawberry Island, which is right here, which is 5.9 miles away. Here's what Strawberry Island looks like up close. Okay, now we're going to cruise up this way. And we're going to go up to Gull Island, which is right here, and there's a tower on this island I'm going to show you, which is 9.9 miles away. And then right here is a tree I'm going to show you that's 10 miles away. Okay, so let's take a closer look out here at 10 miles. Okay, so here's our tree right here, first tree. And then we'll keep going to the left here. And here is Gull Island, here's the tower. Here you can see the tree and the tower at the same time. So we got trees at 3 miles, 6 miles, and 10 miles. Let's see what they look like in reality. Okay, so here's Strawberry Island at 6 miles. Now I looked at the horizon with my naked eye, and then I matched the camera zoom to match your eye, so it looks the same. Now here's the 3 mile tree, and here's the trees at 10 miles. So the first thing you should notice is that the horizon is right at 3 miles, just like it should be. So that's a match. Now let's move Strawberry Island over so we can compare them. Okay, here's the trees that are at 3 miles. Now that's how far you can see, so there's no hidden curvature there. Now on the left side is Strawberry Island, and at 6 miles away, there should be 6 feet of curvature, so the bottom of the tree should be missing by 6 feet. And that makes kind of sense. Look how it's a little bit lower than the 3 mile trees. Now in the middle, you got your 10 mile trees. Now those trees are supposed to have 32 feet missing, and you can see they're half as tall, so that makes total sense. In reality, what we see as far as Earth curvature goes matches the way our eyes work, according to science. The horizon that we see 3 miles away is a physical horizon, and those trees in the background at 10 miles, the bottom is gone because it's being blocked by Earth curvature. Now, here's where the problem comes in. What happens when you use a super zoom camera? And check it out. Okay, there's that first tree, and you can see the ground underneath it.
The horizon is here. These trees should be half gone, hidden by water. That's a big problem.
And let's go to the left there. You can see all the ground under the trees. There's a barge. Okay, there's the tower on Gull Island right there. And we'll come back over here. Okay, there's that little marker right there. That's 3 miles out. So we go from 3 miles to 10 miles. Where did all that curvature go? Okay, so the horizon was here at 3 miles. Let's zoom back in a little bit. And now the horizon is here at 10 miles. So obviously the horizon is not physical. Do you think you can just zoom through the water and see the bottom of the trees again? Let's come back over to here. The bottom of the barge is right here, and the horizon is up there. Now, how is it the horizon in the background is higher than the barge? We live on a ball, right? The ground or the water is supposed to be pitching down and away. The horizon is above the barge. That doesn't make any sense. But let me show you why. Let's lay a hallway over the lake. Now you see how the hallway ramps up to eye level? Well, the lake does the same thing. What they're calling a ball or a globe is just the way your eyes work. It's perspective. The lake ramps right up to eye level. In case you think it was a fluke, here's a different day. Sometimes I come out, it looks like this. The atmosphere isn't cooperating. Here's another day where I can see the tree and all the ground underneath it. Here's another day. So I've done it many times. Yeah, it's not a fluke. So you don't see no hidden curvature at 10 miles. So obviously when you zoom into Strawberry 6 miles away, you can see everything. So maybe years ago, we didn't have high zoom cameras, but we have them now. I mean, what's the chances? What's the possibility of such a huge coincidence that our eyes match the curvature of the Earth? Our vision was hijacked, and they called the Earth a ball.